So there's 8 different sampling methods that you need to know about. 4 of them are probability-based techniques, and 4 of them are non-probability-based techniques. We're going to be talking about each of them in a fairly general sense. When it comes time to answer questions about them, particularly in the exam, it's very important that, as well as knowing the general what each of these are, you can apply them to a scenario. And so for different scenarios, the way that you apply a particular technique may be slightly different. So this is something very important to keep in mind, particularly as you get closer to the exam. So a non-probability sampling technique is pretty much just what it says. It's one which has not been selected through some sort of random method. There is normally some sort of personal judgment on the part of the researcher. So the person who is conducting the sampling is in some way or other picking the people that are in it. One of the big disadvantages of non-probability sampling is that it is more likely to have bias and makes it much more difficult to generalize to the general population. The advantage of the non-probability methods is they tend to be a bit quicker and easier to use. So we might use them more for finding qualitative data, and for some of our earlier work before we go about a more formal and larger sampling in order to collect quantitative data. Probability sampling, on the other hand, is where we have some sort of random method of selecting our sampling units. Ideally, each unit has an equal chance of being selected, but this can vary method to method, and is something that we can address later on when we're doing analysis. The nice thing with the probability methods is they are less likely to be biased, and particularly biased by the selection, and they will allow us to make better and hopefully more reliable inferences about our population of interest. So just a quick summary of the non-probability versus probability. So probability we would consider to be more conclusive, whereas the non-probability is more of an exploratory type of sampling. There's more potential for bias, and in the non-probability, and particularly if we're going to be trying to do any quantitative methods, the statistical considerations tend to favour probability sampling. And then when I'm saying operational considerations, I guess that's the cost and effort. It's normally easier to do non-probability sampling than it is to do probability sampling, and it comes down very much to what kind of data we want to collect, how reliable it needs to be, and what we're going to do with it as to what method we choose. Sometimes we may have 2 elements. We might be looking for interview participants. We might use non-probability sampling to try and pick some interview participants, and then probability sampling for our more quantitative questionnaire and surveying. So our first method is convenience sampling. And so convenience sampling is exactly what it sounds like. You're just picking people because they happen to be in the right place and the right time. It's easy. So it's quick and it's easy, but there's a very strong chance of having bias. So really common convenience sampling would be where you see people in shopping centres where they have the little clipboards and they chase after you. Anytime you see questionnaires that are just sitting on a website and people can answer them, or you have your TV text-in polls, things like that, are all examples of convenience sampling. So basically it's a quick and easy way of getting a sample. Big problem is that it's only going to have a very limited sample frame. You can imagine that if I was, for instance, picking people at a shopping centre, and I'd highlight that this is shopping centre selection is just one example of convenience sampling. It's not the only way of doing it. But if you were picking people at a shopping centre, then only people who come to that shopping centre on that day have any chance of being selected. And so that's quite a strong bias that will potentially then bias whatever data you collect off those people. So our second method, judgment sampling, still is non-random and is still got a potential for bias. Basically, the researcher is using some sort of judgment to pick people. It could be that this is kind of tied in with the convenience sampling. Maybe they're at a shopping mall or they're somewhere convenient, but they're trying to apply a little bit more judgment. So they might kind of say, okay, well, I'm going to select this person for this reason, I'm going to select this person for this reason. You won't be able to generalize to populations, and there is a chance of bias, but it can be quite useful. I mean, if I was doing a pilot study and I was wanting to test my survey instrument, I would use what would be judgment sampling, where I would go and I would intentionally pick particular kinds of people to test my survey out on. So there is uses for it, where I would be applying my judgment to choose who is in my sample. If I was doing interviewing, I might be using my judgment to select my sample for interviewing as well. With quota sampling, we're still non-random, and basically we would come up with some particular quotas for characteristics or demographics. So we might decide we want a certain percentage of men and women, or we want a certain percentage of different age groups, or we want a certain percentage of different ethnic groups, or different kinds of consumers. And so normally we would then do some sort of convenience or judgment sampling, but we'd be applying this idea of a quota to it. So if I was in the shopping mall or wherever I was, I wouldn't just be selecting any old person. I'd be keeping track of these characteristics to try and make sure that I am getting the right percentages of the different age groups and genders and so on. There is still this strong possibility of bias, and particularly if I have my quotas wrong, I could actually be creating more bias. So not necessarily ideal, but it may give us a little bit more accuracy, or certainly more representativeness across these characteristics than if we just did a straight convenience sample and we just grabbed whoever was handy. Okay, our final non-random, non-probability method is snowball sampling. So snowball sampling is where we select some initial group of respondents, and I've said that they're selected at random. They may be at random, they may not be at random, but basically if you imagine a snowball rolling down a hill and it gets bigger and bigger and bigger, it's the same kind of idea where I will find an initial group of respondents, it could be random or non-random, and then I ask them to find more respondents, and then those people are then asked to find more, and then the next group of people are asked to find more. So each time someone gets recruited into your sample, they get asked if they can recruit more people into your sample. So this might seem like an unusual way of going about collecting a sample, but for some, trying to find some particular groups, and particularly very small and unique groups, this can be very useful. We can't have a lot of faith in the statistical results we get from it, but certainly for qualitative research, for interviewing and focus groups and things like that, it does get used quite a lot. I've seen it in a number of masters and PhD projects where it's been maybe slightly unusual or a very small group that the researcher is interested in, and it's been a good way of finding them. So you can imagine if I wanted to find maybe people who were suffering from a particular disease, or had a particular condition, or had a particular hobby that was very unusual, or were maybe some sort of minority group in some particular way. If I just go out and do random surveying street to street or telephone, interviewing or anything like that, it's going to be very hard to find these people if there's no particular list. For some diseases, there may be support groups or lists or foundations that you can go to, but for some there might not. But what you tend to find is that if you can find one or two people who have this condition or have this unusual hobby or have this unusual characteristic, quite often they know other people through their own social networks who also fit the same criteria. And so the recruitment ends up being done largely by these people who know other people who fit the criteria that you're looking for. Okay, so that's snowball sampling. Now we're going to move on to our probability-based or our random sampling techniques. So our first one is simple random sampling. And so simple random sampling, you can imagine that I have my population, and then I get my sampling frame. My sampling frame is hopefully some sort of list of people or elements that I can choose from, and in this very simplest way, you can imagine I just number them, and I get some random numbers to draw some random people or random elements, and that's my sample. So it is very much just take a list and then through some random process, so maybe random numbers, select people off that list, and that is my sample. Sometimes this is all you need. It's for a statistician, it's much easier to analyze than the other probability methods, and it is quite simple to explain. It can be simple to do sometimes. If I have a list of email addresses and I just randomly pick some of them and email people, it's very nice and easy for me to do. If I had to go and see the people face to face, maybe I was doing medical research, I had to take blood from them, then simple random sampling might not be very good. If my population of interest was all the people in Australia, and firstly getting a list of all the people in Australia could be tricky. Probably the best I could do would be something like the electoral roll, and then I selected people and I had to travel all around Australia to find these random people. It would be very difficult and very expensive. In fact, really it would be impossible to be able to do. So sometimes simple random sampling is just nice and easy, can be administered well. Sometimes though, particularly if we're dealing with like travelling over large geographical areas, it's not so good. Okay, and my next one is systematic sampling. So systematic sampling is a little bit different. It starts from a random starting point in my data, and so it's the random element to it. And then after that, we go through and I've said ith, so I is going to be a number. So it might be every 5th or every 10th or every 20th or 100th or 200th element, and select that item or that person. So the way that I work out I is I get my population size, and then I divide by my desired sample size. And the random starting point will be somewhere between 1 and I, and then from there I'll just count through. So it might be every 20th or 25th or 50th or whatever I is calculated to be, that's how many I will count through. For some data this is very convenient. You can imagine if I was auditing and I have a whole lot of numbered receipts, sampling every 100th receipt or every 50th financial document, very convenient. If I'm doing quality control and I'm looking at batches coming through some sort of manufacturing process, then every 20th batch or every 15th box or every 100th item I can perform quality control checks on. So basically if I've got data, I've got some sort of ordered list to sample from, then systematic sampling can be very convenient. It's not going to work for every situation, and I do need to be a little bit careful. If I'm counting through every 20th or 50th or 100th, there is a small chance that I could miss some sort of pattern that's occurring in my data just by taking these